the midpoint in that situation. So in triangle ABC, BO or OB is equal to OC equal to capital R. We have taken these two sides are equal, okay, of this. And if I take these two triangles, triangle thus, and OD is perpendicular, and OD is, we have drawn OD perpendicular to BC. This implies that triangle BOD is congruent to triangle COD. Try to understand. Right angle, two angles are equal. This angle A, this angle A. Why? The angle subtended by an arc on the center is equal to angle subtended by on the center of the circle is twice of the angle subtended by the same arc on the circle, okay, in other parts of the circle or in, okay, on the circle, okay, other than this. So this is how, or any point, if any okay, angle subtended by the arc on the center is twice of the angle subtended by it in the major section or other section of the circle. Okay, so this is how this angle is twice of this angle is equal to angle A. I mean twice of angle A is equal to this angle. So these two angles are equal, A angle. So therefore these two triangles are congruent. So in this triangle, therefore in a right angled triangle, which one? BOD, we have, so let us take sine A angle. Sine of A angle. Sine of A means sine of angle at right angle, which is angle BOD. Sine of angle BOD. Sine of angle BOD is equal to BD upon hypotenuse is OB. Now BD is A by 2 upon this is OR. Sorry, OB is capital R. I'm sorry. This is circumradius, and this is sine of angle A. So sine A is equal to A upon 2R. 2 will come in the denominator, so 2R, A upon 2R. So this implies that twice R is equal to small a upon sine capital A. Twice R is equal to this. That means we have proved twice R equal to A upon sine A. Similarly, if I change the denominator, we can prove, let me write here. Similarly, we can prove find B upon sine B is equal to twice R, and C upon sine C is equal to twice R. Therefore, it's implies that A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to twice R. Okay, so this is proved. The circumradius of a triangle is or twice of that equal to A upon sine A, B upon sine B, C upon sine C. With this we have proved. Now second part of this, let us prove. Yes guys, now if I take, what is the value of this twice R? We have proved that twice R is equal to, since twice R is equal to A upon sine A. This we have proved. Okay, so this implies that R is equal to A upon 2 sine A. A upon 2 sine A. Try to understand. Now we know that what is sine A means. Sine A will be This is A upon, if I put value of sine theta, which is 2 sine theta by 2 into cos theta by 2, let me substitute that value, which will be nothing but 2 sine A by 2 into cos A by 2. This is A upon 4. A upon 4, it will be into sine A by 2 into cos A by 2. Got the point? Now what are the values of sine A by 2, cos A by 2 in terms of semi-perimeter, in terms of size that we know about, but we know that, let me write. Now this is R value. R we have to take as A upon 4 into sine A by 2 into cos A by 2, or we can just take this value. This is A upon 4, now sine A by 2 in terms of semi-perimeter form. Okay, that let me write here. That is equal to sine A by 2 is, since let me write here. Where? Let me write here. Let me write here. Since sine of A by 2 is equal to square root of s minus b into s minus c divided by bc, and sine cos A by 2, sorry, and cos A by 2 is equal to under root of s into s minus a upon bc. These are the values of sine A by 2, cos A by 2. If I substitute these values in this case, it will be under root of first sine A by 2, which is nothing but s minus b into s minus c divided by bc into cos A by 2. What is cos A by 2? This is s into s minus a upon bc. Now, what do we get from here? This bc, under root bc and under root bc square will be cancelled out, but this will come in the numerator. This will be a into bc. This bc, which is under root bc in the denominator, or this a is divided by this upon this will come in the numerator. Okay, so this bc, which is without now denominator, without radical sign, will come in the numerator. So this is abc upon 4 as it is. Within the square root, we are left with s minus a into s minus b into s minus c, which is nothing but area of the triangle. So this is ABC upon 4 into capital S, which is area of the triangle. Capital S is under root s into s minus a, s minus b, s minus c. That is area of the triangle. Therefore, this is the value. Hence, we have proved here. Hence, capital R is equal to ABC upon 4 into S, where capital S is under root S into S minus A into S minus B into S minus C. This is the value here. Okay, so this is the area of the triangle. Hence proved. So finally, the second part is also proved. B part is proved. Now let us take 11th question, number 11. What is question 11 say? Let me check it. Let me check that. Yes. Question number 11. Before that, let me clean this guy. Let me clean this. It's very dark. Yes. Now question number 11. Let us take question 11. If the length of the sides of a triangle are 3, 4 and 5 units, then R, the circumradius, is what? That we have to find out. Okay, so let's take that value. Question number 11 is objective type question. If it says the length of the length of the sides of a triangle, the length of the sides of a triangle, we say of a triangle ABC, it says, or any triangle of a triangle R3, 4 and 5 respectively, right? Then circumradius, okay, then what is the, then R, the circumradius, is in how many units? Then capital R, that is the circumradius, this is circumradius, okay, is what? Let me first find it out. Now here we see that if I take a triangle here, let me take, this is a triangle, right angle triangle in this case, this is ABC, okay. Now C is, okay, these are the sides here, sorry. If I take ABC like this, let me take this is ABC. Now C is the right angle in this case. Why? Because the side opposite to C, this is 5 centimeter, C is 5 centimeter. Side opposite to angle C is 5 centimeter. And this is 4, let me take side opposite to B, 4, this is 3. What we see, this is the right angle triangle. So C is the right angle triangle. So sine of C is 90 degree. So C upon sine C, here, solution let me find out. Here, angle C is 90 degree, as 5 square equal to 3 square plus 4 square. So 25 is equal to 9 plus 60, which shows that it is a right angle triangle. Right angle triangle, and the right angle that C. The bigger side is C here, third side C. That I have taken C here. Any side can be taken, but that is C here in this case. The biggest angle is C. So this is right angle here. Therefore, C upon sine C is equal to twice R. We know that since this is equal to this, so C, which is 5, or 5 upon sine 90 degree, try to understand, is equal to twice R. That means R is equal to 5 by 2 into sine 90 is 1. This is 5 upon 2. That means 2.5. Try to understand. Circumradius is 2.5 centimeter. Units, this is given centimeter or units only. Okay, so this is in units, I think. Units. So this is 2.5 units, which is the answer number B part, which is 2.5. Answer B is correct. Okay, so in this way we can calculate, because now sin 90 degree we know about what is 1. Sin 90 is 1 here, so sin 90 equal to 1, and R is equal to therefore 5 upon 2, but 2 will come here. Therefore R is circumradius, this is radius, answer units. This is the answer here. So capital R, circumradius is 2.5 centimeter or 2.5 units. when no radius, no units is given, only units it says. So this is question number 11. Now let us talk about question number 12. What does question number 12 say? Let me check it. Question number 12 now. Question number 12 says, if a small r is the radius of in circle of a triangle ABC, and prove the following formulae. Let us take that. If a small r, now this is a small r, if r is small r is the radius of the in circle, radius of the in circle of a triangle ABC, then prove that. What will prove here? First proof is AB have to prove that small r is equal to s upon small s. This is the first part. B is small r is equal to 4 capital R, okay, into sin A by 2, sin B by 2 into sin C by 2. This is multiplication. This is B part here, and C part is small r is equal to s minus a into 10 a by 2 for capital A. 10 a by 2 is equal to s minus b into 10 capital B by 2 is equal to s minus c into 10 c by 2. This is the third part of this. Small r is equal to s minus a into 10 a by 2, s minus b into 10 b by 2, s minus c into 10 c by 2. All these things we have to do. Now, if I take small r is equal to s upon small s, then these three parts can be grouped from one to other. I mean, if I take suppose third part, s minus a, and then put the value of 10a by 2, then calculate the other terms, that can also be done. Now, but I have to first prove that what is the value of small r, in this case, capital S upon small s or not. Let me take that with the help of triangle. This is solution here. Solution, or we can just prove, because if I substitute the value of sin A by 2, sin B by 2, and okay, and capital R also, the value of capital R in terms of sin, which is sin is A upon, I can just sin A. In that way, this value can be cancelled out. Capital R, so this small r can be taken then in terms of capital S upon small s. That can be done. Okay, but before that, let me take this question now in terms of this is in circle here. Now let me take this in circle. If I take a triangle, let me take a triangle here. Let me prove this in my own manner. This is A, B, and C. Now if I draw a circle, in circle, and this is in circle here. In circle, no problem. Then we are having, suppose this is the center here, and this is joining these points here, and this is, let me take O point. This is small r, radius of this small circle. Okay. Now in this case, we have just drawn the perpendiculars. Okay. Or we have joined the midpoints of these sides. So this is small r, which is the radius of the in circle. Here. If I take, let me take the length up to this point, or these points, let me take different way. A, B, C, and D. This is D here. E, let me take, and this is F here. I've taken here. With the length, and if I take this A, or this is here the midpoints here, okay, of the side. From A, this distance AF is equal to AE. Let me take, this is alpha, this is also alpha. And this is, let me take beta here, and this is length beta. BD is beta length. Okay, or any length we can take. we can take D1, D2, D3, etc. D1, D1, D2, D2, D3, D3, and this is gamma we have taken, and this is also gamma. So this CD is equal to CE. This is gamma gamma length we have taken. Okay, so in that way we will take this. Now let me take. If I take this triangle, okay, this is joining the point O to B and to OC also. Okay, and here the medians we can say, and these medians are intersecting at this point. This we have taken. So, okay, this is 2:1 ratio, 2:1 ratio, 2:1 ratio. No problem. Now, what is the values here? So, if I take first thing, small r is equal to s upon capital S upon small s. What we see, and the length of these sides are, this is small a. If I take the complete length, this is b here, whole length, and this is c here, because opposite to angle c, we have taken the length of the triangle as this and this. Okay, there is the point here. Now in this case, and center we have taken O, not a problem at all. Okay, and that question I have taken here. So if I take find the area, okay, if I find the area, because these are the perpendiculars, OD is perpendicular to base BC, BC is A. If I find the area of the triangle, so in this case, area of the triangle ABC, area of the triangle ABC is equal to area of triangle BOC, area of triangle BOC plus area of triangle COA plus area of triangle BOA or AOB, no problem, AOB. All the three triangles we have taken this and this and this. Here the perpendiculars here. We have joined the, we have dropped the perpendicular from the vertices A to D. D is the perpendicular here, and this BD. So now, but D is not the midpoint. Otherwise, this B equal to gamma. D is not a midpoint. Here the just perpendicular drawn from the vertices to the opposite sides. Okay, so this D is the, this is a right angle, this is right angle, we can say this is right angle here. Alright, so the area of these triangles. Now this OD is perpendicular to BC, we can say, but this AD was perpendicular, AD is perpendicular to BC, or OD is perpendicular to BC, same thing. So OD is the height of this triangle. It will be half base EA, therefore areas are 1.2 A into R, try to understand, plus half, this is B into R, plus half, this is C here, C into R. So this total area of the, this we are finding out area, delta or capital S, let me take. This is equal to 1.2 R. If I take common, it will be A plus B plus C. Try to understand. So what is the area? This capital S are taken the area. This is area here, area of the triangle. Area of the triangle ABC. Area of the triangle ABC I have taken capital S, which is equal to 1.2 R. I have taken common from this because this is base A into height R, half A into R, half B into this R, half C, this is C length, before the angle C, this is C length here, C into R. All the three angles, triangle or area of three triangles will give us area of the bigger triangle, the mother triangle you can say. Okay, so that is this equal to, but this A plus B plus C is twice S, we know. So twice small s upon 2 is already there into r, 2 to cancel out. What we see, this implies that small r is equal to capital S upon small s. Try to understand. It has been proved. This is because small r, we have obtained small r is equal to small r into small s. This is small s here. So small s will come in the denominator. So r is equal to capital S upon small s. This is the first part we have done. Okay, so we have proved this. Therefore, area of the triangle capital S is equal to. Therefore, capital S was equal to r into small s, or small r is equal to, this is radius of the incircle, capital S upon small s. Proved. This is the first part we have proved. Okay, so this is the first part. And let us take other parts also. What are the other parts here? Now we have to prove that what is small r. Okay, so small r will give us sin a by 2, sin b by 2, sin c by 2 is also there. So small r we are given. If I take the value of this small s and this, that can also give us the same thing. Okay. Now if I take from the first result, the second result can be obtained easily, but that I am not going to do. I will take from this triangle here. From this triangle, if I take the same values here, what is small a here? This is small a. Here is small a is BC, which is BC, or BC equal to small a is equal to how much? This is beta plus gamma. Beta plus gamma. Okay, so this is value of, or we can take this is BD plus DC. If we take BD plus DC, this is BD plus DC. Okay, so this length is how much? What is gamma value, or DC is what? Now DC we have to calculate in terms of R, suppose. Well, this value is to be calculated in terms of small r or capital R, no problem. So that is there. So we have to just calculate what is the value of DC, what is the value of BD. That will give us small a here. Small a, we have to just take that. I have just calculated these values. Okay, so let me take them in the same way. Now if I take this DC in terms of R here, okay, and angle is, now this is angle A here. This is angle A. The angle subtended at the center is twice of the angle at A. That will give us, or if I take the other, angle bisector. So if I take these in terms of angle C by 2, this is C by 2 angle. This is angle B by 2. This is angle B by 2 here. In terms of angle B by 2 and the C by 2, if I take them, so what is BD? BD is BD upon OD. So if I take BD, since BD upon OD, OD is R here, BD upon OD in terms of angle B by 2. So this is base here, base upon perpendicular is cot theta, we cot B by 2. That means BD is equal to OD cot theta. OD is R, so small r into cot B by 2. Similarly, from this CD will be R into cot C by 2. So these values are R into BD is R cot B by 2. And this is small r cot C by 2. This angle is C by 2. But take in this right triangle, which one? COD, cot C by 2 is, this is base DC upon perpendicular OD. OD is R, so R into cot C by 2 we have taken. This will give us, so small a is equal to R cot B by 2. Now let me put here R. Now cot B by 2 is cos B by 2 upon sin B by 2. plus cot c by 2, or I have taken common. This is cos c by 2 upon sin c by 2. Okay, now let me solve it further. Okay, so let me take it here. This is a, we are calculating. Small a is equal to small r within bracket. Now it is cos b by 2 sin c by 2, cos b by 2 into sin c by 2 plus cos c by 2 into sin b by 2 after taking LCM. In the denominator we are having sin b by 2 into sin c by 2. So in the numerator we are having r into, this is sin a, let me take this sin b by 2 cos c by 2 plus sin c by 2 cos b by 2. So this is nothing but sin a plus b formula. This is b by 2 b plus c by 2. So sin b plus c by 2, okay, divided by this sin b by 2 sin c by 2. So this is sin b by 2 into sin c by 2 in the denominator. So we have obtained this a into this. Therefore r is equal to, let me write here. Therefore this is small r into, now this is sin b plus c by 2. So if I write here 90 minus a by 2, it will be sin 90 degree minus a by 2. What the point? Divided by, this is small a equal to, we are calculating sin b by 2 into sin c by 2, sin b by 2 into sin c by 2. Okay, so in the numerator we are having sin 91 is cos theta. This is cos a by 2. So cos a by 2 we have obtained here, cos a by 2. Okay, so if I just substitute this value, let me write here. So we have obtained a is equal to, now a equal to r into cos a by 2 angle, divided by sin b by 2 into sin c by 2. This value we have obtained. Okay, now let us take this further. So r cos a by 2. Okay, and this is, but a, we know what is a value. Small a, we know that this is twice r into